everyone. So today we're going to be evaluating piecewise functions. We're going to look at level 1 today and then level 2 in the next lesson. So first, let's define what a piecewise function is. A piecewise function is a function divided into parts, and each part is defined by a domain restriction. This can be an equation or an inequality. So when you see piecewise, I want you to think that it's a function that is separated into different pieces. Here it says parts, but you can think pieces. So here's an example. We have f of x equals x plus 5 when x is less than 4, and we have 2x plus 6 when x is greater than or equal to 4. So this piecewise function is defined by whether the input value is less than 4, which is this first part, or is greater than or equal to 4, which is this part. So we're going to take a look at an example so we can see how to evaluate these and how to apply this. So here we have f of x equals x minus 3 squared minus 2 for when x is not equal to 3, and then f of x equals 2 for when x is equal to 3. The first thing we're going to do is identify the input value. So that we're going to get from this part here, find f of 3. Hopefully you recognize that means x is equal to 3. Step number 2, determine which domain restriction the input satisfies. So these are our domain restrictions. So which one does this apply to? Is x not equal to 3 or is x equal to 3? So we can see here that x is equal to 3 in this case. So this is going to be the part of the piecewise function that we're going to focus on. We're not even going to look at this part. We don't need it because x is equal to 3. Now evaluate the function based on your domain restriction. So you can see here, sometimes we're going to have to plug in and simplify. Sometimes we're not going to have to do that. It's just equal to that number. So that's the easiest case scenario. So how we write this is f of 3 equals 2. And that is our answer here. So that means when our input is 3, our output is 2. Now, if our input was not 3, then we would have to apply this function, and we would have to evaluate that. But because our value is 3, this is our answer, and we leave it just like that. Let's take a look at another example. So here we have f of x equals x squared minus 2 for when x is not equal to 0, and then f of x equals negative 6 for when x does equal 0. Okay, so step number 1, identify the input value. So hopefully you can recognize here that that means x is equal to negative 1. Now we're going to determine which domain restriction the input satisfies. So we know that x is equal to negative 1. It's not equal to 0, right, because negative 1 and 0 are two different numbers. So this is the part of the function that we're going to be looking at. X is not equal to 0, which is what we have. We have x is equal to negative 1. So we're going to focus here, and we're just going to get rid of this part. So now we're going to evaluate the function based on that domain restriction. So we're going to, as we would any other normal like evaluating function question, we're going to take our input and substitute it in for x. So here we have f of negative 1 is equal to, instead of writing x squared, we're going to put negative 1 squared. I'm going to use parentheses there. Make sure you always do that. Minus 2. So we're just taking that negative 1, plugging it in for x. Now let's do this exponent here. Negative 1 squared is the same as saying negative 1 times negative 1, which is positive 1. And then I'm going to bring down the minus 2. And I'm going to bring down that f of negative 1. And then we know 1 minus 2 is negative 1. So our answer to this one is f of negative 1 equals negative 1. Okay, so always identify what your input value is, determine which domain restriction that input value satisfies, which one makes sense, and then that's going to be the function that you evaluate. Sometimes we're going to have an equation, sometimes we're going to just have a number.